Let's review together a population growth problem. The following problem has to do with money, with investments, rather than other species that we have seen until now. We have worked with population growth problems on fish, frogs, bacteria, but we haven't seen what is happening when we consider money. Does it work the same way? Well, yes, because we are working with an exponential function. Again, so let's look at this problem. Someone has invested his money, some principal, on a specific investment. And he follows the growth of this investment over the years. We want to find out what is the amount that was invested at the beginning, what is the doubling time for the specific investment, and now we are 13 years after the initial investment, and we would like to see how much money does this investment worth. So let's start. One of the important questions right here is what is the doubling time of the money? Since we are referring to doubling time, the formula that we should use is P of t equals to P0 times 2 to the t over A, where P0 is the initial population, in this case the initial investment that we had, and A is the number of years that takes for this population to double. In order to answer our questions, we have to focus on the specific graph. So the first question is, what is the amount that was invested? So this should be the initial investment, meaning the initial population. Whenever we look for the initial population, we focus on the y-intercept, meaning 0, y. So we look at the y-axis, and as you can see right here, the point where the curve crosses the y-axis is at 100. So the y-intercept is going to be the 0, 100. And this expresses that in 0 time, meaning at the beginning of the investment, he invested exactly $100. The next question is, what is the doubling time? Well, looking at the graph, and since he invested $100, we want to see how long did it take for this money to double. 2 times 100 is equal to 200. So we want to find out how long did it take for the investment to reach at the point of 200. And as you can see right here, the curve is at the point 4, 200. So the point that identifies the doubling time is 4, 200. The money became $200. And the time, the corresponding time, is 4. So it took 4 years for the money to double, from 100 to 200. The next question is, now that we are exactly 13 years after the initial investment, we would like to know how much money does this investment worth. So we need to go at 13 years and look at the point that we have right here. And this should be very close to 900. As you can see, we are missing this point, but this doesn't matter. Why? Because we can calculate it. We want the P of 13. And the P of 13 is going to be equal to 100 times 2 to the 13 over 4. Why 4? Because 4 is the number A, is the number of the years for the initial investment to double. So we are looking for 100 times 2 to the 13 over 4. Now, 13 over 4 is 3.25. In order to calculate that, we should use the calculator. But we don't want to use the calculator, so we want to approximate this number. 2 to the third is 8. 2 to the fourth is 16. So the number should be around 10. So the amount of money that he has right now is approximated to $1,000. Another question that is asked is, how much money will he be able to withdraw after 11 years from now? Since we are now 13 years after the initial investment, we are asking the question, how much money will he be able to withdraw at 24 years, 13 plus 11? In order to do that, we have to calculate the P of 24. And this is going to be 100 times 2 to the 24 divided by 4. This is equal to 100 times 2 to the 24 divided by 4, that is 6. So this is equal to 100 times 64, that is $6,400. So, if you invest your money, $100, in an account, in an investment that doubles your money every 4 years, then in 24 years you are going to withdraw $6,400.